What is the negative x-intercept of the graph of the quadratic function f of x equals 5x squared plus 4x minus 1? Hold on, Layla. Now, keywords are negative and x-intercept. Layla, in words, explain to the class what an x-intercept is.
I can explain it.
Okay.
The x-intercept is
That's the x-axis. What's the x-intercept?
where it intersects on the x.
Correct. No.
I got this.
We all know that a y-intercept is where the graph crosses the y-axis. So an x-intercept is where it crosses the x-axis. Well, the easiest way to locate an x-intercept would be to what? But like where? On the left side because it's negative, but I mean, I'm missing a key thing here. What's the best way to do this? No. Graph it. And look at the picture and see where it crosses the x-axis on the negative side. So on the graphing calculator, you'll type in that equation, which is y equals 5x squared plus 4x minus 1. Okay, and then you graph it. Remember, an x-intercept is where it crosses the x-axis. So this parabola has two x-intercepts because it crosses there and there. But they only cared about the negative one, which is at negative 1. So the correct answer is D. Okay, now I need you to turn to page 8 in your packet. You were supposed to do 1, 2, and 3 for homework. If you didn't do it, you need to do it over the weekend so that you can at least get a late stamp. I am about to do 4, 5, and 6 with you. Now, before I take the time to write these in standard form, I'm going to first identify some key features of the function. What is the most obvious thing that lets me know that this is going to be a parabola? The squared. The exponent of 2 lets me know that it's going to be a parabola. If your highest exponent is a 1, it's a linear function. If your highest exponent is a 2, it's a parabola, a quadratic function. So, I know that this is in the form y equals a times x minus h squared plus k. So what is the a value? 7. What will that a value tell me about the parabola? The a value tells you whether it opens up or down. No. The sign of the a value tells you up or down. Since it's a positive 7, it's going to open up. Since it is 7, which is greater than 1, it's going to be a vertical stretch. Now, what is the h value? Negative 9. Now, let me clarify because I know that's confusing. Because when you see x plus 9, you're probably thinking, well, why is the h a negative 9? Well, think about it. The formula is x minus h. If you plugged in an h value of negative 9, that's how it became a plus in the middle. The minus and the negative became plus. Yes, for a vertex form, it'll always be a, h, and k. Now, that's just the formula, just like y equals mx plus b. Somebody just decided a long time ago they were going to call slope m and b the y-intercept. Okay? What does this negative 9 do to the parabola? Right. No. Remember, it's correct. But now you see, but now it makes sense to you because the h is really a negative 9, which is why you're going left 9. And then the k is 5, which will move it up 5. So, if your entire graph, including its vertex, moves left 9 up 5, what is the vertex's location? Correct, which is your h and your k value. The vertex is just your h and your k. All right, now we are going to take the time to rewrite it from the vertex form that it was given to us in, and we're going to rewrite it in standard form, which is y equals ax squared plus bx plus c. Okay, so here we go. the first thing you do is you just basically rewrite it with one exception. Instead of actually writing x plus 9 squared, we're going to go ahead and write out what that means. It means x plus 9 times itself. So you write it twice. And then don't forget to bring down the plus 5. From this point, we're just going to start simplifying, following order of operations. So the first thing we need to take care of is parentheses. Whenever you have a binomial times a binomial, you distribute. So that'll be x times x, which is x squared, x times 9, which is 9x, another 9 times x, which is 9x, and then 9 times 9, which is 81. Okay, now in the next step, I'm still not going to do anything with this outside 7 or plus 5 because I can still simplify what's inside. Because 9x plus 9x is 18x plus 81, right. Now what do you think I can do? Distribute the 7 now because multiplying comes before adding in order of operation. So that'll be y equals 7x squared plus, what's 7 times 18? Right, 126x plus, what's 7 times 81? Okay, and since I've run out of room, let's go ahead and combine the step. What am I going to do to that 567 next? Add the 5 to it, which will be 572. So now that you've simplified it, what's the A value? Just 7. What's the B value? And what's the C value? Now remember, guys, the A value is 7, just like it was in vertex form. That will not change. So like on a multiple choice test, if you're looking at 4 answers and this was 7, but then one of the answers doesn't have an A value of 7, you can go ahead and mark that off. It's not the right answer. Their A values have to be the same. Yes. So think about it. Say that you have 4 choices, and 2 of them do not start with a 7x squared. You eliminate those. Then say you really don't remember how to do all of this work. Can't you graph this one and graph the 2 remaining choices and see which parabola matches with this one? Does that make sense? Remember how we talked about checking it? How if you graph this one and then you graph the standard version of it, the standard form version of it, they should make the same parabola? Okay, go ahead and graph this in y1 and graph that in y2. I'm going to just let y'all. Number 5. Okay, remember, I'm going to say this again. How do I know that this is going to be a parabola? It's squared. Anytime your 2 is your highest exponent, it's a quadratic equation which forms a U-shaped graph called a parabola. This parabola has been given to us in vertex form, which is y equals a times x minus h squared plus k. Our goal is to change it to standard form, which is y equals ax squared plus bx plus c. But before we even start that, we're going to talk about some other stuff. What is the a? -2. The negative will make it open down. The 2 is larger than 1, so it'll be a vertical stretch. Not super skinny because it's just 2, but it'll still be stretched a little. Okay, what is the h value? A +3. That minus is from the formula. It does not belong to that 3. Okay, what will that +3 do to the parabola? Right 3. Remember, the number inside parentheses is a horizontal shift. Okay, and then what is the k? And that will do what to the parabola? Down 9. So if your parabola shifts right 3 and down 9, that places the vertex where? 3, -9. Remember, your vertex is just your h and your k value. Pay attention. Okay, now that I've done all that, I'm going to take the time to rewrite it from one form to the other. So here we go. No, not this one. Y equals -2 times x minus 3 squared But instead of squaring it, I'm going to go ahead and write out x minus 3 twice, because that's what squared means. And then minus 9. Now I'm going to start simplifying it by first taking care of all of that stuff in parentheses. And when you have a binomial times a binomial, you double distribute. First you distribute the x to everything over there, then you distribute the negative 3 to everything over there. And that becomes x squared minus 3x plus 9. Because a negative 3 times a negative 3 is a positive 9. Now, I'm still not going to do anything with the negative 2 or the minus 9 because I still have simplifying to do right here. The negative 3x minus 3x combines to a negative 6x. Now I'm ready to distribute that negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 6x is positive 12x. Negative 2 times 9 is negative 18. Just 18, there's no x. And then don't forget about this minus 9. Then in the end, we'll combine with that negative 18 to make your final answer negative 27. So the A is still negative 2, just like it was in vertex form. The B is 12. And the C is negative 27. Okay, I'm going to give you like 2 minutes to try number 6 by yourself. Go. This is a parabola. The way we know is because it's squared. It's given to us in vertex form, so we should be able to identify the A, the H, and the K. What is the A? 1. Since it's a positive 1, the parabola will open up. No, it's neither. It's neither. It has to be greater than 1 to stretch, less than 1 to shrink. If it's exactly 1, it doesn't do either. It's just like it's like the parent function, the standard width. Okay, what is the H?
Oh, I know the H.
A positive 8, which will move it right 8. What is the K? Which will place the vertex where? Right. Remember, your vertex is your H value, comma, your K value. Now we are going to take the time to rewrite this in standard form. There's not. Okay, so you start by writing x minus 8 twice, because that's what it means to square something. Now you have x times x is x squared. X times negative 8 is negative 8x. Negative 8 times x is another negative 8x, and negative 8 times negative 8 is positive 64. Bring down the minus 5. Now all you have to do, since there was no number on the outside to distribute, you're almost done. You just combine like terms and get x squared minus 16x plus 59, which makes the A value 1, just like it was before. That does not change. Negative 16 and 59. Okay, turn to page 9. We're going to start the new stuff. The new equation is y equals negative, oops, too big, negative parenthesis x plus 8, negative on the outside, parenthesis x plus 8 parenthesis squared plus 1. Okay, that is a parabola, we know, because it's squared. It's in vertex form, so we should be able to recognize the A, the H, and the K. What is the A value? Negative 1. What is the H value? Negative 8. And what is the K value? 1. What will this A value do to your parabola? No. No. The only thing it's going to do is turn it upside down because it's negative. Since it's 1, it won't be a stretch or a shrink. It has to be greater than 1 to stretch, less than 1 to shrink. No. The absolute value of negative 1 is 1. You have to kind of think of the negative and the 1 as separate things. They do two different things. The negative flips it. The 1 is just 1. Okay. What does H being negative 8 cause the parabola to do? Left 8. What does the k being positive 1 do to the parabola? Up 1. So we can go ahead and graph our vertex by leaving the origin and going left 8, up 1. So 1, 2, 3, 4, 5, 6, 7, 8, and then up 1. Okay, now, we know it's going to open down, but to figure out exactly where the points are, we're going to graph it on the calculator. So go ahead and graph that in the calculator. Y equals negative, parenthesis, x plus 8, parenthesis squared, plus 1. It's on the board. Okay, once you have it typed in for y equals, you will graph it. But even seeing a picture of it doesn't really give us the points that we're looking for. It just confirms that we were right about the vertex being left 8 up 1 and about it opening down, correct? To find points, you go to the table. Now, before I do, look up here a second. Look up here. Look up here. Aren't all of the points going to be on the negative x side and the negative y side? Okay, so when you go to your table, you need to, yes. Okay, let me take it off speaker. Hello. Let's continue. So look, we're looking for points that have a negative x value and a negative y value. Well look, don't all of these numbers that are on the screen have negative x values and a lot of them have negative y values, except for a handful? So let's plot some of these. I don't really care to do the negative 12, negative 15. Let's start with negative 11, negative 8. So go ahead and plot that point. I went to second graph. Okay, so look, plot negative 11, negative 8, which means go left 11, down 8. Yes, left 11, down 8, because look, on your table, one of the points you see is negative 11, negative 8. Now the next point we could plot is negative 10, negative 3. So go left 10, down 3. I know, it's not easy. But okay, look at it this way. We know to get to that point we went left 8, so 9, 10. And now just go down 1, 2, 3. This one? Yeah, left 8, up 1 because of that and that. Okay, now, this one? This one? That one was negative 11, negative 8. And then we plotted negative 10, negative 3. And now I'm about to plot negative 9, 0, which would be right here. And then look, the next point is negative 8, 1. Well, we already plotted that one. That was our vertex. So then the next point we get to is negative 7, 0, which will be right here. Now let me show you something. So look up at the screen for a second. I don't know, I'll have to watch. Okay, I need y'all to watch for a second. Okay, let me show you a couple of things. I could have already told you that there was going to be a point here and here. This is important. I could have told you there was going to be a point here and here. Because if this is your vertex and your A value is negative 1, I know to get to the first 2 points, you go down 1 over 1 and down 1 over 1. Okay, because it's a negative 1. Had it been a negative 2, you would leave here and go down 2 over 1, down 2 over 1 to get to the first 2. But that only works for those first 2 when you leave the vertex. Okay? Now, to find the rest of them, instead of going back to the table, watch what else you could do. Isn't the axis of symmetry going to go right down the middle of the parabola through the vertex? And aren't parabolas symmetric? So look at what we can do. Look. If this point is 2 units away on this side from the line of symmetry, there's another point 2 units away on that side because they're symmetric. If this point is 3 units away from the line of symmetry, then over here there'll be a point 3 on this side. And isn't that a little easier to find those instead of going to the table every time? Yes. Okay, so now that you have that many points, that's sufficient. You can sketch your parabola. Okay, now that we have it sketched, we are going to answer some questions about it. Okay, here we go. When you hear the word domain, what do you think of? X. Now remember, the x-axis runs in two directions, left and right. When you list the domain, first you list left, then you list right. If you're on this parabola and you want to travel left, that you would start out and you'd go to the left side, how far can you go? Right, because as it's going down, isn't it also slowly moving out to the left a little? And you can go left forever, which is negative infinity, because left. How far could you go to the right? Positive infinity, because I know it's going down, but it's positive because it's going right. Now, if the domain is x values, which is left to right, range is y values, which is down to up. You always do the negative to the positive, so that'd be negative to positive. So how far does the parabola go down? So negative infinity. How far does the parabola go up? 1 on the y-axis. And since it stops there and never goes above it, you put a bracket. Now, zeros is a new word for us. Zeros are just x-intercepts. How many x-intercepts does this parabola have? 2. And where are they located? Well, yeah, almost. Negative 7, 0 and negative 9, 0. No, you could put negative 9, 0 first and negative 7, 0 second. Okay, now the y-intercept, no, they're points. So parentheses always go around points. The y-intercept we didn't find because we didn't continue drawing points. And think about it. At this rate, the y-intercept is going to be way down here. But how could you look at the table and know where the y-intercept is? Where was at 0? Yes. Okay, so if you go back to your table and go to where x is 0, right. So the y-intercept is 0, negative 63. Okay, we're not going to talk about interval of increase or decrease today because that's also new and I don't want to overwhelm you. Max and min or not. What is the maximum point on this parabola? No, the maximum point, isn't the vertex the highest point on it? And where is that point located? Negative 8, positive 1. Okay? No, there's no minimum because it goes to infinity, so does not exist. Alvarez, pay attention. Okay, now in behavior, when x approaches negative infinity, what do the y values approach? So you're telling me as you go to the left side, right. As you go to the left side, you're going down. And as you go to positive infinity, which is the right side, you're still going down. Parabolas will always match up because think about it. They behave the same way on the ends. Either both ends are going up or both ends are going down. So if this is negative, that has to be negative. If this is positive, that has to be positive, which makes it even. If they behave the same way, it's even. Okay, so if these match up, it's even. With linear, it would have been odd because with linear equations, don't the ends behave the different ways? One goes up, one goes down? Okay, now let's look over at this one and try this one. This is the last one. I'm about to give you the equation. Okay, the equation is y equals 2, parenthesis, x minus 6, parenthesis squared, minus 2. So, that is a parabola. The way I know it is because it's squared. It's in vertex form, so I'm able to identify the A, the H, and the K. What does the A tell me? Or what is it? Okay, yeah, 2 is greater than 1, so it's going to be a vertical stretch. And is it going to open up or down? Up, because it's a positive 2. What is the H? No, positive 6. Remember that minus is from the formula, x minus h. So it's just a positive 6, which will shift the parabola how? Right 6. And what is the k? Down 2. So we can leave the origin and go right 6, down 2, and that is your vertex. So if you want to go ahead now and draw the line of symmetry, you know it goes straight up and down through the vertex. Your axis of symmetry will cut the parabola in half, which has to go through the vertex to do that. Now, the rest of your points can be found by going to the table, or remember that hint I gave you about finding the first 2 points? You look at your A value. Since your A value is 2, the first 2 will be up 2 over 1 and up 2 back 1. And then from there you can find the rest of them from the table, so go ahead and graph it. Y equals 2 parentheses, x minus 6, parentheses squared, minus 2. Okay, so what does that mean you should do? Go down until you find smaller numbers. Okay, so I'm going to go to the table. Oh, right, that was one of those points we found by knowing the A made it go up 2 over 1. Okay, hold on, I got to get down to some points I can look at. Okay, so I'm getting into some points that I can actually plot. So like 4, 6, 5, 0, 6, negative 2, 7, 0. We already plotted 3 of those. So let me plot 4, 6. 1, 2, 3, 4. Up 1, 2, 3, 4, 5, 6. Well, if there's a point right there and it's 2 units from the line of symmetry, wouldn't there be 1, 2 units on that side? Okay, and since we're running out of time, go ahead and sketch it. We'll finish. We won't do any more points. Okay, now the domain. I didn't say we were finished. What's the domain? How far will it go left? Negative infinity. How far will it go right? Positive infinity. What's the range? No, it only goes down to here, which is at negative 2. How high will it go? Infinity. What are the zeros? Look at them. They're right here on your table. Oh, I went too far. And this is... Okay. 5, 0, and 7, 0. Okay, y-intercept, we don't see right now. You'd have to look at your table, so we'll skip it since we're running out of time. 70, 0, 70. Okay, what's the maximum? Well, it goes to infinity, so the maximum does not exist. What's the minimum? 6, negative 2. The max and min are points, which means you need an x and a y value. Okay, as x approaches negative infinity, what do the y values approach? Look, guys, if you go left or right, you're going up. So both of these are positive infinity. And since they match up and go the same direction, that's even. When they behave the same way on the ends, it's even. You may switch out.